Hello my dear students, welcome to my YouTube channel. So today we are going to solve 20 best MCQ problems aiming for CBSE 2025 board examination, and this is part number 7. All the links of the previous parts will be in the description box. Please go and check them. So further any ado, let's start. Question number 1. Possible reflexive relations in a set A whose n of A equal to 2. What is the meaning of n of A? N of A equal to 2 means A has 2 elements. Okay, 2 elements. Okay, so let us take A equal to small a and small b. Now, the reflexive relation R. So, what is the condition R to be a reflexive relation? R has to have this element and this element. If any of these two elements is absent, then R will not be a reflexive relation. Okay, so we have to take this element and this element, then we can take another elements from A cross A. How many elements are there in A cross A? There are 4 elements because n of A is equal to 2, then A cross A has 2 into 2, that means 4 elements. Okay, so there are 4 elements in A cross A, from them 2 is already taken, so this has to be in the R, and then we can take another elements to make a relation R, that is reflexive. So we can take none of the elements, this can be a reflexive relation, and like this is we have taken with this phi, then there are remaining 2 elements, that is A comma B and B comma A. We can take one element at a time, either this element and or this element or both. So that means there are other 2 options elements, so that we can make from this 2 to the power 2, I mean that means 4 subsets, so that R is a reflexive relation. Okay, that is I am trying to say this is one reflexive relation and this is second reflexive relation. A comma B is there. Now with it A comma B and R3 A comma A, B comma B and B comma A, sorry, this will be B comma A, B comma A, and R4 will be the whole A cross A, I mean 4 elements, that means 1 2 3 4. There are 4 possibilities of relation that will be reflexive, so option number C is correct, 2 square. Okay, I hope you understand. Next problem, question number 2. If A and B are 2 collinear vectors, then which of the following is incorrect? Remember, it is incorrect, we have to mark. So B is equal to lambda A for some scalar lambda, this is correct, so this is not the answer. And A equal to plus minus B, this is also correct, so this is not the answer because here lambda is equal to plus minus 1. This is a special case of this. Okay, then C, A dot B. Okay, I am coming to this later. Option number D, the respective components of A and B are proportional. This is also correct, that means this cannot be the answer. So C option is correct because A dot B is 0 when A and B vector is perpendicular, then A dot B is 0, and if A, B are collinear vector, then A cross B is 0. So this means this is incorrect, that means this is the answer. So option number C is correct again. Okay, next problem. Problem number 3. for which of these vectors is the projection on y-axis is 0. Okay, so among these three vectors, which vector has a projection on y-axis 0? Let us take this vector as a vector. Okay, and now any vector on y-axis is looks like b j cap, where b is non-zero scalar. B is non-zero scalar. Okay, so okay, first dot product a and b. This dot product, now this is mod a vector, mod v vector and cos theta. This is something like, let us take, this is c. Okay, this is c. This is a scalar quantity. Okay, now mod a cos theta. Okay, mod a cos theta equal to c by mod b vector. Okay, this is bj. Now this is the projection, on y-axis. Now mod of v not equal to 0, so that means a cos theta should be 0. That means mod of a also non-zero, because see that here all the vectors are non-zero, so mod of a is non-zero. We are taking this vector as a vector, and then we will take this vector as a vector. This vector will also be a vector. So any of these three, mod of a is non-zero, so that means cos theta should be 0. Okay, cos theta should be 0. This is 0. So theta is 90 degree. In other words, when we dot product them, this vector with bj, like this, dot bj and dot this dot bj. Okay, then as the j component is absent here, that is why I dot j will be 0 and k dot j will be 0, because I and j, k and j are perpendicular. That means cos theta equal to cos 90 degree, that means 0. For option number A, when we dot product them 2j into bj, okay, then the dot product will be 2b. This is not equal to 0 as b not equal to 0. So that means 2 and 3 give a projection on y-axis 0. So that means D option is correct, only 2 and 3. Okay, I hope you understand. Next problem. Problem number 4. If A equal to this matrix and B equal to this matrix, then and A equal to B square, then X equal to what? Okay, A equal to B square, so we will find B square. This is x1 0 1 into x1 0 1. Row and column, x square, then 0 into 1 0, and next 0 plus 0. Second row, first column, x plus 1 and then 0 plus 1. So this is x square, x plus 1, 0 1. Okay, now this is equal to 1 2 0 1. So comparing x square equal to 1, so x equal to plus minus 1. Now if x equal to plus 1, then this is 1 plus 1 equal to 2, and so we have again x plus 1 equal to 2, that means x equal to only 1. From here we are getting x equal to plus minus 1, and here we are getting x equal to 1, that means 1 will be the solution. C is correct option. because here if we put minus 1, x equal to minus 1, then this will be 1, but this will be 0. Plus 1 and minus 1, this will be 0, but here it is 2. So that means x equal to 1 is the only solution. Option number C is correct. Next problem. Problem number 5. For any 2 cross 2 matrix P, which of the following matrices can be Q such that PQ equal to QP? Okay. P is a 2 cross 2 matrix and it is said that PQ equal to QP. We know that in general the matrix multiplication is not commutative. In general, matrix multiplication is not commutative. Commutative means PQ not equal to QP in general. But if you take Q equal to the identity matrix, then PQ equal to P into I, this is equal to P, and this is also equal to Q into, I into P, and also Q equal to I, that means I into P, that is Q into P. So Q equal to I satisfies this. So that means Q has to be identity matrix. So B option is correct. This is the identity matrix 1001. So B option is correct. Okay, next problem. Question number 6. The function fx equal to x mod x belongs to R, is differentiable only at x equal to 0, in R only at x equal to 1, and in R minus 0. So let us check, because fx equal to, it is given that fx equal to mod x mod x. So mod x has the definition break at x equal to 0. So this we will rewrite it as x into minus x when x less than 0, and x into x, this is when x greater than equal to 0. So we have a definition break at x equal to 0. So that's why we will check only at x equal to 0 point. Otherwise, in every point other than that x equal to 0, this fx is differentiable, and hence you know that it is continuous. So we will check at x equal to 0. So let us check the left hand derivative. What is left hand derivative? This is limit h tends to 0 f of x minus h minus f of x divided by minus h. So what is f of x minus h? X minus h means, sorry, x equal to 0, this will be 0, because we are checking at x equal to 0. So this we can write it as 0, this is 0. So 0 minus h, that is f of minus h, and this is f of 0 divided by minus h. So what is f of minus h? F of minus h is, because h is less than 0, minus h is less than 0, that means we have to take this definition. So that means limit h tends to 0, f of minus h is minus x square, and what is f of 0? F of 0 is 0 divided by minus h. Sorry, this is minus h square. Sorry, my mistake. This is minus h square. So minus cancelled, and h square by h, this is h, and h tends to 0, that means this is 0. Now check the right hand derivative. Okay, right hand derivative is easy, because this is limit h tends to 0 f of h minus f of 0 divided by h. So this is h square by h, and limit h tends to 0. So this is also 0. So left hand derivative and right hand derivative both are equal. So left hand derivative equal to right hand derivative. Okay. So we can say that fx is differentiable everywhere in R. So I have said before that it has a definition break at x equal to 0, That's why we have only checked at x equal to 0 point whether it is differentiable or not. Otherwise, in any other points different from 0, it is differentiable. And we have checked that at x equal to 0, left hand derivative and right hand derivative are equal. That means it is derivable, differentiable at x equal to 0. That means throughout R, it is differentiable. So option number C is correct. Differentiable in R. Next problem. Question number 7. If y equal to log this, then dy dx equal to what? So y equal to log 1 minus x square divided by 1 plus x square. Okay. That means y equal to log 1 minus x square minus log 1 plus x square. Okay. So differentiating dy dx, this is equal to 1 by 1 minus x square. So the derivative of log x is 1 by x, and then the derivative of 1 minus x square is multiplying. So this is minus 2x. Again minus log 1 plus x square, the derivative of log x is 1 by x, and then the derivative of 1 plus x square is 2x. Okay. So now this is equal to minus 2x by 1 minus x square and minus 2x by 1 plus x square. So minus 2x common, this is 1 by 1 minus x square plus 1 by 1 plus x square. Okay. So now this is equal to minus 2x, LCM is 1 plus x square and 1 minus x square, this is 1 minus x to the power 4, and in the numerator this is 1 plus x square plus 1 minus x square. So from this we are getting what we are getting? We are getting minus 2x into 2 divided by 1 minus x to the power 4. That means minus 4x by 1 minus x to the power 4. Okay. So that means B option is correct, minus 4x by 1 minus x to the power 4. I hope you understand. Next problem. Question number 8. A ladder 5 meter long standing on a horizontal floor leans against a vertical wall. If the top of the ladder slides downwards at the rate of 10 cm per second, then the rate at which the angle between the floor and the ladder is decreasing when lower end of the ladder is 2 meter from the wall. So what is saying? This is the vertical wall and this is the horizontal floor, and a ladder is like this. Now the top of the ladder is decreasing its height at 10 centimeter per second. Now this is 5 meter long, so that means we have to convert it in centimeter, that means 500 centimeter. Okay. So now this is the angle between the ladder and the horizontal floor. So this is the theta, and we have to find d theta by dt. The given that dx by dt, this is equal to 10 centimeter per second. Okay, what is x? This distance is x, suppose, and when d theta dt, when this distance is 2 meter or 200 centimeter, this distance, then what is d theta by dt? Okay, so this is a right angle triangle, this angle is right angle triangle. So what is sin theta? Sin theta is equal to x by 500, that means x equal to 500 sin theta. Now we have given that dx by dt 10 centimeter per second. So taking derivative, so dx by dt. Now here in this side, right hand side, it is sin theta. So we have to derivative it like this, d dt. So taking derivative with respect to t, and here also in the right hand side with respect to t, that means 500 sin theta. Now this is, we are writing d theta and 500 in the outside, this is sin theta, and now d theta by dt. Okay, now what is 500 and derivative of sin theta is cos theta. Now this is d theta by dt. Okay, now I am writing here in the left hand side. So this is dx by dt, this is equal to 500 cos theta into d theta by dt. We have to find this quantity. Okay, so that means d theta by dt is equal to dx by dt divided by 500 cos theta. Okay, what is dx by dt? This is 10 divided by 500 into cos theta. That means this is equal to 1 by 50 cos theta. Now to find cos theta, we will use that the base of the right angle triangle is 200 centimeter. So when base is 200 centimeter, then what is cos theta? Cos theta equal to 200 by 500, that means 2 by 5. So we have got cos theta equal to 2 by 5. So we will put this cos theta equal to 2 by 5 in this expression, that means 1 by 50 into 2 by 5, that means 5 by 50 into 2, that means 1 by 20 radian per second. Because this theta is in radian, we have assumed, not in degree. So what is the answer? Answer is option number C. Okay, so 1 by 20 radian per second. Option number C is the answer. Okay, next problem. Question number 9. A linear programming problem LPP along with the graph of its constraints is shown below. The corresponding objective function is z equal to 3x plus 2y. The minimum value of the objective function is obtained at the corner point 2, 0. Okay. The optimal solution of the above linear programming problem, okay, does not exist at the feasible region is unbounded. Okay, so we have found the minimum value 2, at this point 2, 0 point. So we have already found that z 2, 0 is minimum, which is 6. So this area is unbounded, but we have to find the minimum value of the optimization function. Because of this, the minimum value can be found at the corner points, but the maximum value cannot be found because the solution region is unbounded. If you take any point here and if you take any point here, then z here is greater than z here. So you cannot find any maximum value of z, but you can find the minimum value, and you have already found at 2, 0. So A option is incorrect. Though it is unbounded, we can found the minimum value. And the optimal solution of the above linear problem does not exist at the inequality. This does not have any point in common with the feasible region. Okay, this is the line 3x plus 2y less than 6, that means x by 2 plus y by 3 is less than 1. That means this is the line. So here the line is not there because this is, I am erasing this. this is 0,4 and this is 2,0. So I think this will be 0,3. So this line is 3x plus 2y less than 6. Okay, does not exist as the inequality does not have any point of common with the feasible region. This is also incorrect because this is the feasible region and the inequality is for this line is, this is the line equal to 6. Okay, so for this line this is 3x plus 2y is greater than equal to 6. This is the constant. Option number C, as the inequality 3x plus 2y greater than 6 has infinitely many points in common with the feasible region. Okay, so this is the greater than 6 and it has obviously infinitely many points in common, but we don't have to find the maximum. This is the minimum value, so this is also incorrect. Now option number D, exist as the inequality 3x plus 2y less than 6 does not have any point in common with the feasible region. This is the correct option because the inequality 3x plus 2y less than 6, this is the region, that region is this, this is the region, this region is 3x plus 2y is less than 6, because this region has no common point with the feasible region, because this is the feasible region, this is the feasible region. So that means D option is correct, that the inequality 3x plus 2y less than 6 does not have any point in common with the feasible region. So this region has no common point with this feasible region. So D option is correct. Okay. Next problem. Problem number 10. The value of sine tan inverse x where x is less than mod x is less than 1. So let tan inverse x equal to theta. That means x equal to tan theta. Okay. So we have to find that this is sine theta, because theta equal to tan inverse x, that means sine tan inverse x equal to sine theta. So tan theta is equal to x by 1, that means this is perpendicular and this is base, that means what is hypotenuse? Hypotenuse, this is root over 1 plus x square or x square plus 1, this, that means what is sine theta? Sine theta is equal to perpendicular, that means x divided by root over 1 plus x square. So that means C option is correct, x by root over 1 plus x square. Okay. Next problem. Question number 11. The domain of sine inverse 2x. So we know that the domain of sine inverse x for x belongs to -1 to 1. It is defined. Okay. So now here it is sine inverse 2x. That means 2x should be belongs to -1 to 1. That is 2x is greater than -1 equal to and less than equal to 1. That means minus half to half, x belongs to minus half to half, and this is closed, that means C option is correct, closed minus half to half. Okay. Problem number 12. If probability of A condition B is greater than probability of A, then which option, which of the following is correct? So what is P of A condition B? This is equal to P of A intersection B divided by P of B. This is greater than P of A. Okay, that means P of A intersection B is greater than P of A into P of B. Okay, I am writing this for the time being. We will check the options. Now, which following option is correct? So, option number B, P of A intersection B is less than P of A into P of B. This is strictly incorrect. You can see from this relation. So, this is not correct. P of B condition A, this is equal to P of B. This is also not correct, because see, P of A intersection B is equal to P of B intersection A. Okay, so P of B condition A, this is equal to P of B intersection A by P of A. Okay, now from this relation we can write P of B intersection A by P of A, this is greater than P of B. Okay, that means this expression is greater than P of B. That means P of B condition A is greater than P of B. So from this given condition we are getting this relation, that means C option is correct. P of B condition A is greater than P of B. Okay, next problem number 13. If the sum of the numbers obtained on throwing a pair of dice is 9, then the probability that number obtained on one side of the dice is 4. Okay, so we are throwing a pair of dice, so that means there are 6 square, that means 36 sample points. Okay, from this we will obtain the sum, total sum 9 as like this: 6 3 and before that 3 6, now 4 5 and 5 4. Okay, there are no other possibilities of getting a sum of 9 from these two dice. And what is the probability? Then the probability that the number obtained on one of the dice is 4. So here we are obtaining 4 in one dice and here we are obtaining 4 in one dice. There are two favorable outcomes, this and total outcome is 36, that means 2 by 36 the required probability, and this is 1 by 18. So option number C is correct, 1 by 18. Okay, next problem number 14. The value of the integral minus pi by 2 to pi by 2 x plus x cos x plus tan x plus 1 dx. So we are writing this as I. This is minus pi by 2 to pi by 2 x plus x cos x plus tan x plus 1 dx. We are separating this minus pi by 2 to pi by 2. This is x plus x cos x plus tan x, and next plus minus pi by 2 to pi by 2 dx, and here also dx. Now we will check that this function is an odd function. Okay, so to check this is an odd function, let us take fx equal to this function x plus x cos x plus tan x. Now f of minus x, this is minus x and minus x cos minus x and plus tan of minus x. So you know that minus x and cos of minus x is cos x and tan of minus x is minus tan x. Okay, so this is minus common, x plus x cos x plus tan x. So you can easily check this is minus f of x. So fx is an odd function, and I have already told that from minus a to a, fx dx is equal to 0 when fx is an odd function. Okay, and when even function, then it is 2 0 to a fx dx when this is even. So now this is this integral is 0, this integral, this is 0. Now the remaining integral, this is, now integration of dx is x, and the upper limit is pi by 2 and the lower limit is minus pi by 2. Now this is pi by 2 minus pi by 2, this is equal to 2 into pi by 2, that means pi. So answer is pi, that means B option is correct, pi. Okay, next problem, problem number 15, the degree of the differential equation is. So what is the degree of a differential equation? The degree is defined as the power or index of the highest order differential present in the differential equation, or the highest order derivative present in the differential equation, the power of that highest order differentiation is the degree. So here the highest order differentiation is 2, because this is d square y dx square, so this is second order derivative, this is first order derivative, and this is sin x, sin dy dx. Okay, but the power of the second order derivative is 2, so you can think that the degree of this differential equation is 2, but there is a catch, because here it is in the argument of sin x sin dy dx, that means this is the argument of a sine function, this is not a polynomial function of a differential equation, or this is not a polynomial function of a simple differential coefficients. That's why the degree of this differential equation is not defined. So D option is correct, this is not defined. Okay, because here sin dy dx is there, this for this term the degree is not defined, but the order of this differential equation is 2, because the highest order differentiation is present here is 2. Okay, so the degree is not defined and the order is 2. Okay, next problem 16, consider the non-empty set containing of children in a family and a relation are defined as A or B. If A is brother of B, then R is which function? So in a particular family the set is containing the children. So suppose there is a boy, girl, boy, girl, boy. Okay, I am taking this. So this R is defined as A is brother of B. So here this B is brother of G, this B is brother of this B, B1, suppose B1, G1, B2, G2, B3. Now B1 is not brother of B1 itself, that means this is not reflexive. So where this is reflexive, so here this is not the reflexive. Okay, if B1 is brother of B2, then B2 is brother of B1. Now B1, if B1 is brother of G1, then G1 is not brother of B1. That means this relation is not symmetric. Okay, so symmetric but not transitive, this option is incorrect. Transitive but not symmetric, neither symmetric not transitive, both symmetric and transitive, this is also not correct, because this relation is not symmetric. Now see, if B1 related to B2, that means B1 is brother of B2 and B2 is brother of B3, then B1 is brother of B3. This is correct, because the medium point B2 has to be a brother, not a sister. If you take B2 as a sister, then this condition is violated, and hence in contrapositive way this relation is transitive but not symmetric. If you found such B2, so that B1 B2 belongs to R and B2 B3 belongs to R, then B1 B3 also belongs to R in the relation. If you found any B2, then it has to be a brother and B1 B3 belongs to R. If you don't find, then contrapositively this R is transitive. So C option is also incorrect, B option is correct. This relation is transitive but not symmetric, and this is not reflexive also. So this reflexive option is not there, but you can check. Okay, I hope you understand. Next problem. Problem number 17. A cylindrical tank of radius 10 meter is being filled with wheat at the rate of 314 cubic meter per hour. Okay, then find the rate at which its depth of the wheat is increasing. Okay, there is a cylindrical contain tank. This is cylindrical tank. Okay, so now this tank has a radius of 10 meter. This is 10 meter. So what is its volume? So volume is pi r square h. So this is, we are taking this as h. So volume is pi into 10 square h. That means 100 pi h. Okay. Now the wheat is filling at the rate of 314 cubic meter per hour. So wheat is falling here. Then the volume of this tank is filling. You can easily understand that. Okay, the volume is filling, that means dV by dt is given. So this is equal to 314 semi cubic meter cube per hour. Now differentiating this v, dV by dt with respect to t, we are getting 100 pi into dH by dt. So simply put dV dt as 314 meter cube per hour. So this is 314, this is equal to 100 pi dH by dt. Okay, now what is dH by dt? This is equal to 314 divided by 100 pi. And what is pi? We are taking 22 by 7. Okay, this is okay, this is 22 by 7, we are writing it 22 by 7, and this is approximately 3.14, so it is 314. So this is cancelling this is 100, and 100 by 100 is 1, so 1 meter per hour. So answer is A, 1 meter per hour. Okay, next problem. Question number 18. Integration dx by e to the power x plus e to the power minus x. Okay, so it is dx by e to the power x plus e to the power minus x. Okay, now dx by e to the power x plus 1 by e to the power x, because x to the power minus 1 is equal to 1 by x. Now this is equal to dx by e to the power x plus 1 by e to the power x, sorry, e to the power x 2x. because this is e to the power x into e to the power x, that means e to the power x plus x e to the power 2x. Now this is equal to e to the power x dx by e to the power 2x plus 1. Now you can write e to the power 2x as e to the power x whole square, because 2 into x, it will be 2x. So that means this is, we are taking this as e to the power x dx, and this is e to the power x whole square plus 1 square. Now see that if we take e to the power x as t, then e to the power x dx will be dt. Okay. Now this integral will transformed into dt by t square plus 1 square, that means tan inverse t plus 1, and tan inverse t is equal to tan inverse e to the power x plus 1 plus c. Oh sorry, this is plus c, I am doing a mistake, this is plus c. Okay, this is plus c. Okay, so what is the answer? The answer is tan inverse e to the power x plus c, that means A option is correct. Okay, this is the answer. Next problem, question number 19 and 20, assertion reason based question. Okay, question number 19, let fx be the polynomial function of degree 6 such that ddx of f of x is equal to x minus 1 whole to the power 3 and x minus 3 whole square. Okay, the assertion is f has a minimum at x equal to 1. Let us check. Okay, so equating f dash x, this is f dash x. Okay, this is f dash x and f dash x is equal to 0. Equating this, we are getting 1 and 3. So the critical points is this. Okay, now we have to find f double dash x. Okay, what is f double dash x? F double dash x is 3x minus 1 whole square into 2x minus 3. Now this is equal to 6x minus 1 whole square and x minus 3. So the second order derivative also failed to tell us the minimum value, either it will be at x equal to 1 or not. Okay, now this is f dot triple dash x, this is also equal to 12 x minus 1, and f fourth dash x is equal to 12 and it is greater than 0. If 4 dash x is greater than 0, that means at x equal to 1 it will be minimum, and at x equal to also x equal to 3 it will be minimum, and the minimum is, suppose I think 0, the minimum value would be 0, and it also occurs at 1 and 3. So this option is correct, assertion is correct, because it is obtaining a minimum at x equal to 1. Now the reason, when ddx of fx is less than 0 for all x belongs to a minus h comma a, and ddx of fx is greater than 0 for all x belongs to a comma a plus h, where h is infinitesimally small positive quantity, then fx has a minimum at x equal to a, provided fx is continuous at x equal to a. So if you understand the continuity and differentiability concept much more in depth, then you can find this reason is true, and there is no scope here to discuss this about this reason to be true. I will make a separate video for this differentiability and continuity with some more difficult concept or more in-depth concept of differentiability and continuity. There I will discuss about this property of the differentiation and continuity, because this is called the epsilon delta or neighborhood property of continuity and differentiability. Okay, so actually the assertion and reason both is correct, and this reason is the best explanation of the assertion. Okay, so A option is correct. Both assertion and reason are true, and reason R is the correct explanation of the assertion A. So A option is correct. I will, don't be sad, I will make a separate video for this concept where I will be discussing about this epsilon delta or infinitesimal property of the continuity and differentiability. Okay, next problem, question number 20. Assertion, the positive position question number 20. Assertion, the position of a particle in rectangular coordinate system is 3 to 5, then its position vector is 2 I cap plus 5 j cap plus 3 k cap. So you can easily check the assertion is incorrect, because if the position of the particle in rectangular coordinate system is 3 to 5, then its position vector will be 3 I cap plus 2 j cap plus 5 k cap. So this is not the position vector, so this is incorrect. Okay, so the displacement vector of the particle that moves from P point 2, 3, 5 to the point 3, 4, 5 is I plus j. So OP vector, what is OP vector? This is 2 I cap plus 3 j cap plus 5 k cap. And what is OQ vector? This is the position vectors of P and Q. This is equal to 3 I cap plus 4 j cap plus 5 k cap. Okay. Now what is PQ vector? The displacement vector. The displacement vector is OQ minus OP. Now this is equal to I plus j. So R is correct, but assertion is false. That means D option is correct, A is false, but R is true. Okay. So I hope you have enjoyed solving these 20 problems. I would suggest that before watching this video, please pause the problems and try yourself to solve the MCQ fast. Then if you cannot solve, please watch my solution, and if you find a better solution than me, please comment it in the comment section. And again, I am requesting that to subscribe my channel, please subscribe and press the bell icon to get notification. And if you have learned something from this video, please like this video and share it to your friends. So thank you, bye bye. So thanks for watching, bye bye.